Now that we have all of our density data, our polymer density data on paper from our measurements, we need to transfer that to a spreadsheet so we can start doing some data analysis with it. So imagine this is my paper. The first thing I need to do is start adding my titles in. And so my first cell at the top is teacher example dash plastic juice cups. And then the next one below that is trial. Okay, followed by mass in grams, volume in milliliters, and density in grams per milliliter. Go ahead and pause the video. Okay, click on the tab where it says your work here and copy down the titles for your data set from the paper at your table. Make sure you choose the right one for the things you were measuring. Pause the video. When you're done, unpause the video. Go. Okay, now that we've got our data in here, we're just going to do a little bit of formatting. Okay, we're going to start by merging the top 4 cells. So I'm going to click on the first one and scroll across until I have the top 4 highlighted. I'm just going to click on this merge cells button, and that puts everything in, turns them all into one cell. Then I'm going to highlight all of my data, all of my cell titles. Okay, and I'm going to click on the more and change the horizontal line, this little paragraph, okay, into center. And now they're all in the middle of the cell. And the last thing I want to do is change the color. So I'm going to click on the paint can, okay, and change it to this nice gray. Okay, it still looks professional, but it shows that it's the header. Go ahead and pause the video and format your titles by changing the color and putting the words in the center and merging the top cell. Okay, when you're finished, unpause the video. Now that we've got the formatting on the titles done, we can start putting the data in. Okay, remember, spreadsheets are not very smart. They can do calculations very fast, but they can't infer what you really mean. So it's important when you put numbers in that you only put numbers in. So I'll type 1, 2, 3, 4, 5, 6, 7, 67, whoops, 6, 7, 8, 9, 10. Okay, when I get to the mass, it's really important that I only type the numbers. If I put 0.7 grams, it's going to think that this is a word. And so the way we let it know that this is a number is by getting rid of the grams, and anytime what you type shows up on the right of the cell, it knows that it's a number. So I'm going to finish typing in the rest of my data. Okay, go ahead and start doing that yourself. Okay, oops, 1.3, 2.4. Pause the video, type in all of your data, and then unpause the video when you are ready. Go. Okay, I'm going to do this super fast myself, okay, and cheat because I'm actually on a computer and not copying from paper. Okay, now all of my data is added to my spreadsheet. The last piece of formatting I need to do is just add borders in, so I'm going to highlight all of my data. Okay, click on these 4 squares next to each other called borders and hover over the all borders and click it. And that adds these nice borders on it. It makes the paper look professional, the table look more professional. And then I'll just change the width of the columns to make sure that they are small enough so that it's only taking up the least amount of necessary space. Okay, you can also do this by hovering until it's blue and then double clicking, and it will automatically choose the right size for you. Okay. Now go ahead and pause the video and finish formatting your data table, and then we'll move on to the data analysis. Unpause the video when you are ready. First thing I need to do is find the density. So I'm done with my paper, so I'm just going to enlarge my screen. Okay, I'm going to find my density by setting an equation that divides the mass, okay, by the volume. So it's the orange cell divided by the purple cell, and it's mass divided by volume. Press enter, and there's my density. And then I can repeat that measurement again by hovering over the blue box and scrolling down, dragging it down, and now I just did it 10 times. I'm checking to see, I get a bunch of different answers here, so I know I need to do some more data analysis before I can know for sure what the density of my plastic juice cups is. So the next thing I'll do is decide if I'm going to use mean, median, or mode. I look at my densities, and there doesn't seem to be any outliers, so I won't use median, and there's no answer that shows up a bunch, so I won't use mode. So I guess I'm just going to use mean. So I'll type mean, and then I'm going to give the code for it. Remember, it's average. It does not know what mean means. I'll highlight the data, close the parenthesis, and press enter, and there's my mean. Okay, go ahead and pause the video, calculate your densities, and then calculate the mean, median, or mode depending on what is most appropriate for your data set. And then unpause the video when you are ready. The last thing I want to do is, on my data analysis, is just quickly check the standard deviation. I want to make sure that it's small and that I had good precision. Notice standard deviation overfills the cell. So I just go back up between C and D and double click. It will re-lengthen the cell so that standard deviation perfectly fits in the box. Now I can type in the code equals stdev, open parenthesis, highlight my data, close parenthesis, enter. And there's my standard deviation. And yep, I was right, it is really small, 0.02. Yeah, that's a very small standard deviation. So I had a pretty precise data as well. So I'm feeling pretty good about whether this is the right answer because I kept getting the same answer over and over again. Now, if I could, I would find the percent error, but since I don't know what the actual density of plastic juice cups is, okay, there's nothing for me to compare it to, so there's nothing I can do to know how accurate my answer is. I can only find the precision. Okay. The next thing I want to do, now that I've done some numerical data analysis, I want to start showing how can I show all this data on a graph. Since I have mass, which is measuring numbers, and volume, which is measuring numbers, I'm going to go ahead and choose a scatter plot to measure my data. Okay. The way that we do this is going to be really important, and so the first thing you need to do is highlight the volume and then the mass. Okay, the way the computer is going to set up the scatter plot is it's going to put whatever you highlight first on the x-axis and whatever you highlight second on the y-axis. We want volume on the x-axis. So I will highlight my volume, then I will press the control key on a window, on a Chromebook, and then highlight the mass. And so now they've both been highlighted, okay, but in the order that I wanted them highlighted in. And then I will go and click Insert Chart, choose Chart Types, scroll down until I find Scatter, okay, and I'm going to go ahead and insert it. Okay, and I'm just going to move it off the top of my data. Pause the video and go ahead and make the scatter plot of the graph that you made. Make sure you highlight the volume and then the mass first using the control button. Okay, unpause the video when you are finished. The next thing I need to do is edit my graph. There are a couple things that are incorrect about this. So I'll go to this triangle in the corner, click Advanced Edit, and now it's going to allow me to start doing some editing. So first thing I need to do is change the title. Okay, this is about plastic cups, plastic juice cup density. Now that I've got a title in there, that seems about right. I do want to keep my legend because I'm going to put an equation there in a second, so I'm going to scroll down some more. Starting with the horizontal axis. Now, it looks like volume is on the y-axis. Google is actually incorrect right here. Okay, I'm looking at this data point, 8.89.7. Okay, 8.8 is actually the volume, okay, of the last point. And so that lets me know the volume is actually on the y-axis. So that means the horizontal axis is actually volume in milliliters. Okay, so I'll let that add there. Now I'm going to click left vertical instead, and that lets me know that the y-axis is actually the mass. Okay, and so now the graph has the correct axes on it. Okay, I'm going to go ahead and add some more grid lines, change this to 10, okay, and do the same thing with the horizontal axis, change it from 5 to 10. More grid lines make it easier to read. And then I'll scroll down some more, all the way to the bottom until I see trend line. Okay, actually go ahead and pause the video. Okay, fix the axis titles and the scales. Unpause the video when you're finished and ready for the next step. Now that I've got my titles all finished, I'm going to go ahead and add a trend line. So instead of being none, I'm going to click linear, and that puts this blue line through it. Okay, it is guessing what is the best line that goes through these points, and it looks like it's pretty good. Okay, it looks like it hits all the points. Not all of them exactly, like this one's a little bit above and this one's a little bit below, but it's pretty good. I'm going to scroll down some more. I don't like this label, it's boring. I want some more information, so I'm going to change it to use equation. And now it gives me the y equals mx plus b here. And I also want to show the r squared value to show how close my data is. And wow, this looks really good. It's r squared equals 1, which means that this line does a really good job of modeling the data. Okay, 1 is the highest r squared value possible. And just for fun, I'm going to go ahead and change it to red and some dark red there. And since it's homecoming week, I'll change the points to black. Okay, that way we are sporting our school pride. Okay, and then I'm done. I'm going to go ahead and click update, and I'm finished here. Now, go ahead and pause the video and finish making the line of best fit with the equation and the r squared value. Unpause the video when you're finished. Next thing I need to do is figure out what does all this data mean. Okay, so I'm going to scroll over here and just make some notes over here. I see my slope, okay, is 1.102, and I got to figure out what are the units on this slope. And I know slope is rise over run. It's the change in y over the change in x. And my change in y is the change in the mass, so that's the grams, divided by the change in x, which is the milliliters. So I see my units are actually grams per milliliter. I recognize this. Okay, this is the density. So this makes sense because that's very similar to the mean density I had before. Then I have my y-intercept. And I'm looking here, it's 0.484. This e negative 3 means times 10 to the negative third. And so that's really adding 2 zeros in front. So that's 0.00484. That's a really small y-intercept. Ideally it would be 0, which it looks like it's almost 0 here. Okay, oops, it's negative. Okay, and the units of the y-intercept are always the same as the units on the y-axis, so that's grams. Okay, this is how many grams I would expect of the plastic juice cup to weigh if it was taking up no space. Now, this doesn't actually make sense, so I know my equation's a little bit off. Something can't weigh a negative amount, okay, but it's very close to 0, which is what I would expect. If something took up no space, it should weigh no mass. It should have no mass. Okay. And then the last thing I want to do is talk about my r squared value, okay, and it's 1. Okay, and so this means that the line perfectly models the data. Okay, now it's probably rounding up to 1, but it's pretty close to perfect actually. Okay, now that I've done all of this, okay, I know what these numbers mean. I'm ready to move on to the next step in my lab report and start explaining what this means by figuring out, now that I know the density, what type of plastic is my plastic juice cup made of. Okay, go ahead, you're finished with the video, go ahead and finish your data analysis to the right of your graph. Tell me what these numbers mean, and then move on to the next part of your lab report.